Today we will discuss center of mass. So what is the center of mass, or why we use the concept of center of mass? Because we are studying the classical mechanics, and we know that in classical mechanics the size of the body is very large. So we have to consider the body as a point object. So how we can consider the huge body as a point body? Then the concept of this center of mass is introduced. Let there is any classical body, it consists of number of masses m1, m2, m3, m4 up to mn, so many masses. But we will consider this body as a point body. Let this point, this P, we will consider this whole body as a point body. So the mass of the whole body is supposed to be concentrated at this point, and this point mass is called center of mass. So the topic is center of mass. In short, it is written as Cm, center of mass. So from the term it is clear that center of mass, it is the point which may lie inside or outside the body, where the whole mass of the body is supposed to be concentrated. So let the center of mass is this, and number of masses are m1, m2, m3 and so on. But for convenience or for simplicity, first of all we will consider center of mass for 2-point object. For 2-point body or 2-point object. So let there are 2 points having masses m1, m2, and we will calculate its center of mass. Then we have to draw the position vectors from this O point. Let the PV for first particle is R1, for second particle is R2, and M1, M2 be the masses. So we will find, or we will calculate the center of mass of this 2-point object. Means this is an object which consists of only 2 points, 2-point masses. Then after that we will generalize it for n particle. But first of all we have to study for 2 particles. So there are 2 masses m1, m2, and r1, r2 be the position vectors of these 2 masses from O. So center of mass is the point. Let this point is this. It is Cm. So this point is center of mass. So center of mass is that mass, that point where the whole mass of the body is supposed to be concentrated. So body is consisting of 2 masses. Therefore the mass at this point is m1 plus m2. Let the mass of first particle is m1, mass of second particle is m2. Therefore the mass of both particles at this point is m1 plus m2. So total mass of center of mass at center of mass is m1 plus m2. This is first equation, that is mass equation. And the position of this center of mass point from O is capital R. Capital R. So we can find the distance, the position of this center of mass from O by using the concept of R1 and R2. So using the method of moments, that is we will use the concept of m1 r1 plus m2 r2 is equal to mr. That is m1 is the first particle of mass of first particle, r1 is the position vector of first particle. Similarly it is for second, and it is for total center of mass. Now the mass, this one, or R, is obtained from this equation, that is m1 r1 plus m2r2 over m, this one, or where m is m1 plus m2. So this is second equation. So these are the two conditions by which we can find the center of mass of two particle system. So we can generalize it for n particle system. So generalize for n particle system. For n particle system, we generalize. So what will we get on generalization? So on generalization, we will get the mass of the object, which is called center of mass, is taken as m1 plus m2 up to mn, so on up to mn. So when for two particles it is sum of two masses, and for n particle it is sum of n masses. So this will be the first equation for mass, and similarly for second equation, that is this one. So for n particles, this equation become R is equal to m1 r1 plus m2 r2 so on up to mn rn over, this is m, this one. So these are the two equations to calculate the center of mass for n particle system. Now what will be the velocity? So we can find also velocity from this second equation, because this is equation for position vector. So we know that velocity is the rate of change of position vector, dr by dt. So we will differentiate this equation on both sides. So we will get dr by dt is equal to d dt of this one, m1 r1 m2 r2 up to mn rn over m, this one. And on separating the derivatives, derivative first term plus derivative second term, third term, and so on. So we will get m1 into dr1 by dt, that is v1, plus m2 v2 so on mn vn over m, that is m is constant. So it is independent of derivative. So it is dr by dt. So capital R is used for center of mass and small r are used for individual particles. So therefore, the equation for velocity dr by dt, that is velocity capital V, or which meaning this is the velocity for center of mass, and which is equal to m1 v1 m2 v2 so on up to mn vn, and over m is multiplied on left hand side, you will get this. Yeah. So what is this? This is mv, momentum, momentum 1, momentum 2, momentum 3, that is momentum of center of mass p is equal to p1 plus p2 up to pn. So we have solved the equation for velocity, but also by single step we can find the equation for momentum. So this is called law of conservation of linear momentum. So next we may find an acceleration. So an acceleration is the derivative of velocity. So we can find the derivative, or we will take the derivative on both sides of this equation, and finally we will get the equation for acceleration. So these are the concepts which we have already used in 10+1 class in physics and chemistry. Similarly, the other physical quantities, that is what is linear momentum, what is angular momentum, and what is torque. So these are some physical quantities which we have already known, that is linear momentum is the product of mass and velocity. You know that P is mv, and angular momentum is the cross product of r and p, and torque is the product of r and f. So these are the other physical quantities which can be used in the further articles. So therefore you can study these terms, these articles in detail from the lower classes or from the lower books, and also it is given in the syllabus of your this year book. Now, so the next topic is different types of frame of references. Different types of frames of references. So we will study two frame of references. First, lab frame, laboratory frame, or it is simple called lab frame, and second one we will use center of mass frame. Center of mass frame or CM frame. So what are these two frames? First, lab frame. So what is lab frame? Basically, when we study the collision, elastic or inelastic collisions, then we will use these frames as the reference frames. So first of all, what is laboratory frame or lab frame? The first frame, lab frame, it is the frame of reference which coincide with the target atom. Let there are two particles. This is first particle, it is second, and this particle is moving, but this second particle is at rest. After some time, this particle will strike on this particle. So the frame which is lying at the second particle, or it is also called target particle, this frame is called lab frame. So and it is at rest. And when we study center of mass for this system, again the first particle is moving and second particle is at rest. It is moving, second particle is at rest. Then the center of mass, what is center of mass? Where is the center of mass? First particle, second particle. So center of mass is lying at any point between these 2 points. Let this is center of mass. When this particle will reach nearer to the particle, second particle, then center of mass will reach here. And when it is again moving, it means its center of mass is also moving towards the target atom or target particle. So we will consider the frame of reference which is coinciding with the center of mass. So that frame of reference is called center of mass frame of reference. So we will study the further articles by using these two types of frames of references. So we will study these articles in the next lecture. Thank you very much.